In this last video, we're going to go over volumes and surface areas. When we talked about area, I showed you that with an area, we are looking at how many squares it would take to fill the surface. With a volume, instead of squares, you're working with little 1 unit by 1 unit cubes. And it's how many of those little cubes will fit inside the container that you're looking at. So we're going to start with a box. So there's our box. The bottom of the box has a length and a width. That's just the bottom surface, but then we have the height of the box. Well, to find the volume, you simply find the area of the base, and this is your base. You find that area, and the area of that is length times width. And then you multiply that by the height. Now, for many of the figures that we're going to work with, that's all you're going to do. It's the same formula, but the letters are going to look different because it depends on what the bottom of your container is as to how you find the area of that. So the length times width is simply the area of the base or the bottom of the container, and then you multiply that by the height. Now, to find the surface area is the area on the outside, or what it would take to cover the box if you didn't have anything overlapping. So, to find the surface area, you'd have to cover the bottom. That's length times width. But the bottom and the top are going to have the same area. So there's 2 of those. The front of the box is length times height. But the front of the box and the back of the box are going to be the same. So there's 2 of those. And then the last thing we have is this end. And the measurements of that, this is still the height over here. So that would be width times height. But that end and that end are also going to be the same. So there's 2 of those. So that's how you find the surface area of any box. It's 2 times the length times width, plus 2 times the length times height, plus 2 times the width times the height. There are other formulas that do basically the same thing. But I think this helps you keep track of how many sides you have. Any box has 6 sides. Now, there are some problems that will tell you a box without a lid. Well, if you didn't have the lid, the volume's going to be the same. Doesn't matter whether there's a top on it or not. You can only get so much in there. We're not going to be overflowing. The surface area, the difference would be you wouldn't have a length times width. You wouldn't have 2 of those. You would only have 1. So that's how you find the volume and surface area of a box. Next thing we're going to look at is a cylinder. A cylinder is basically a box that has a circle on the bottom. I told you we were going to see how these are related. If this is a circle, you should be able to find the radius. And it also has a height. So over here I told you that the volume of a box is simply the area of the bottom, length times width, times the height. Well, to find the volume of a cylinder, it's very similar. You have the area of the base, which is pi r squared. That gives you the area of the bottom, and then you multiply it times the height. So that's how you find the volume of a cylinder. To find the surface area of a cylinder, first of all, just like the box, you have a bottom and a top that are the same size, and they're circles. So in order to cover those, you have to cover that area and that area. Well, the area of a circle is pi r squared, and if there's a top and a bottom, there's two of those. Now, with a circle, we have to find the area of the sides. Think of a can, maybe a soup can, because it has a label on it that can be taken off. If you take the label off, what do you have? You have a rectangle. The height of the rectangle only depends on how tall the can is. So the height of the rectangle is the same as h. Well, what's this measurement? Well, think of the label of the soup can. That went all the way around the can. What do we call it if we go all the way around a circle? That's the circumference. So this has a measurement of 2 pi r. That's the circumference of a circle. So to find the area of the outside of the can, it's a rectangle. You would simply take 2 pi r and multiply it by h. So that's the formula for the surface area of a cylinder. It's 2 pi r squared, because that's top and the bottom, plus the surface area of the sides of the can, which is simply a rectangle that has a length of 2 pi r and a width of h. So that's how you find the volume and the surface area of a cylinder. Next, we're going to look at a sphere. A sphere is simply a ball. It's not perfect, but it's not too bad. A sphere also has a radius. You find the center of the sphere and you draw a segment to the sphere, and that's your radius. The volume of a sphere is 4/3 pi times the radius cubed. Now, a sphere is very similar to a circle. If you're given the diameter, the radius is still half the diameter. So find the radius, or it's given to you, and you cube it, or you multiply it by itself 3 times, multiply it by pi, which we're using 3.14, multiply it by 4, and then divide that by 3. To find the surface area of a sphere, the surface area is simply 4 pi r squared. This really doesn't relate to what we did with the box and the cylinder, because a sphere doesn't really have a height or a base. A sphere is just a sphere. It's all the points that are the same distance from the center. One other figure that we're going to look at, and that is a prism. Actually, a box is a prism. But a prism has a base that can be any polygon. It can be a rectangle, it could be a square, it could be a triangle, it could be a hexagon, it could even be an octagon. We're not going to give you the real hard ones. Let's look at a triangular prism. A triangular prism has bases that are the same shape. This will look more three-dimensional if I make these dotted. To find the volume of a prism, it's usually given as B times H. The capital B, and this is important. Some of you that interchange your capital B's and your lowercase b's, this makes a difference. This isn't just a side of the figure, of the prism. Capital B stands for the area of the base. So no matter what shape your base is, if you find the area of that base, then you simply multiply it by the height to get your volume. In this case, because this is a triangular prism, the area of the base is 1/2 times the base times the height of the triangle. Well, remember, with a triangle, you find which side you're going to use for the base, and then you draw a perpendicular to the base, and that's your height. So in this case, I would start with 1/2 the base times the height of the triangle. And then you have to multiply that times the height of the prism, which I'm going to call capital H, simply so that there's a difference. We'll use a capital H up here also. Okay, but that's why usually when you see this formula written out, you will simply see it written out as capital BH, where the capital B represents the area of the base. But that way you're not having the same variables used more than once. But that's all you have to do. And that's what we did with the box also. We looked at the area of the base was length times width, and then we multiplied that times the height. Okay, those are the formulas that you need for finding the volumes and surface areas of boxes, cylinders, prisms, and spheres.